Alright, I think this is like part 3 of this assignment. Okay, we've done the first 5 problems, and now we're going to do the last 2 problems. We are graphing quadratic functions, alright? Functions that have that x squared in them. And so they're going to make these parabolas, like you can see in the problems we've done. But we're dealing with 2 different forms. We've got standard form, which is like this with no parentheses, and then we have vertex form, which is like this. So they're handled a little bit differently. So watch carefully and you'll learn how to graph them in vertex form and in standard form. Problem number 6. This one is in vertex form. This is what you call vertex form. Now, the beauty of vertex form is you can look at it and know what the vertex is immediately. The vertex is going to be the opposite of this one, and then comma that one. So we have a -2 in here, so the vertex is going to be a +2 comma. This one stays the same. So the vertex should be +2 comma 2. Opposite of this one stays the same. Let's go ahead and put our vertex on the chart in the middle. So 2 comma 2. Let's go ahead and graph our vertex. Okay, 2 comma 2. We should know whether or not this parabola is going to be upward facing or downward facing just from the equation alone. Can you tell me? This parabola is going to be downward facing like this because the a value is negative. That tells you it's going to be downward facing. Okay, now if we have 2 in the middle of our graph because of the vertex, we can get the other x values by going less than 2, 1, 0, and greater than 2, 3, 4. We can get the y values, of course, by using our TI-30 XS multi-view. Let's type this in. So -2 times x minus 2 squared. Hit your table button. Okay, so -2 times x minus 2, close parentheses, squared. And I think it was +2. Let me look back. X minus 2 squared plus 2. Okay, I think we got that right. Hitting enter about 5 times will get you to the table. 1, 2, 3, 4, 5. Now, the x value are at 0, so I'm going to scroll till 0 is at the top. Okay, so my y values are -6, 0, and 2. So -6, 0, and 2. We knew that would be 2, but it's nice to see it happening just as we planned. Now, because of the symmetry of a parabola, well, I should be going like this. Because of the symmetry of the parabola, if this is 0, this should be 0. If this is -6, then this should be -6. But as long as we got the calculator going, let's verify it. Okay, so we're expecting a 0 next. Bam! 0. Next we're expecting a -6. And there it is. Okay, so we could go ahead and graph these points right now. So 0, -6. 0, comma, -6 would be right here. 1, comma, 0. Okay, there's your 2, comma, 2. And then the symmetry kicks in. 3, comma, 0. And 4, comma, -6. Alright, it probably won't fit, but always look to see if the next value will fit. Excuse me. But the next value is 5, comma, -16. -16 is way off the graph. So we will have to make do with these 5 values. Let's go ahead and draw the parabola. Bam! There's our parabola. Now let's go ahead and draw that nice axis of symmetry right down the middle. Alright, there's our axis of symmetry. Now we should be equipped to answer some of these questions. They want the vertex. Well, we knew from the beginning the vertex was 2, 2. Is this a maximum or a minimum? Well, look, it's at the very top of the parabola. That makes it a maximum. Does this parabola face up or down? Well, we knew it would be facing down because of the negative a value, and sure enough, it's facing down. Axis of symmetry. The axis of symmetry is a vertical line at 2. Vertical lines always have the equation x equals something, so x equals 2. Do not leave off the x equal part. It is very important. Don't just put 2. The zeros are the x-intercepts. So we have one right here at 1, 0, and another one at 3, 0. The y-intercept is where the graph touches the y-axis. It's always 0, something. In this case, 0, -6. The domain is the x values. So it's how far to the left and to the right the graph goes. Well, this parabola goes left forever and right forever. So that's -infinity to +infinity. The range is the y values. So it's how low the graph goes and then how high the graph goes. It must be in that order, bottom to top. So in the bottom here, it goes down forever. So that's -infinity. In the top, it goes up as high as 2. So -infinity to 2 is the range. And it must be in that order, -infinity to 2. Alright, the 2 gets a square bracket to show that 2 is part of the parabola. It's included, the parabola touches 2. You can see the 2 right here in the vertex. It's definitely included. You can never reach infinity, so all infinities get the round parentheses. Okay, great. That was problem number 6. Depending on you have your paper numbered, this problem might be numbered problem number 3. That might have been number 3 for you. Okay, now let's move on to problem number 7, which might be numbered number 4 on your paper. This one is in standard form. This is what is referred to as standard form. Okay, there's a fly in here. Standard form, people. So when we're talking about standard form, it's important to be aware of your A value, your B value, and your C value. Alright, A is 1, B is -2, and C is 3. It's important because the axis of symmetry, can be found using the equation x equals opposite of b over 2a. Notice I don't say -b, I say the opposite of b. And here's why I say it that way. B is -2. So the opposite of b is +2. If this had been a +2, I would have put a -2. So think of it as the opposite. It will be easier for you. And then over 2a. Well, a is 1, so that's just 2 times 1. So that just simplifies down to x equals 2 over 2. 2 divided by 2 is 1, so x equals 1. This is the equation of the axis of symmetry. It all came from this formula. Okay, so this is what we do when we have standard form. They ask us for the axis of symmetry anyway. So let's go ahead and record it. X equals 1. Now, the axis of symmetry also tells us the x value of the vertex. We always like to put the vertex right here in the middle. So, since the axis of symmetry is x equals 1, the x value of the vertex will be 1. Okay? That one became this one. Now, for the other x values, going less than 1, we have 0, -1. Going greater than 1, we have 2 and 3. For the y values, we go to the calculator. TI 30 XS multiview. 1, -2, -3. Hit your table button. Okay, so it was 1x squared, or just x squared, minus 2x minus 3. 1, -2, -3, right? Okay, so there it is. I find hitting enter 5 times gets you to the table. 1, 2, 3, 4, 5. We want our table to start at an x value of -1. So let's scroll to an x value of -1. Now the y values are 0, -3, -4. 0, -3, -4. Now because of symmetry, the balance of the parabola, if this is -3, we're expecting this to be -3. If this is 0, we're expecting this to be 0. This should be mirror images of each other across the axis of symmetry. So, but let's verify by scrolling down from here. Okay, so if I scroll down one more, I expect to see -3 and then 0. So there's my -3 and there's my 0. So it's sort of self-checking. If that doesn't happen, if you don't see the values you're expecting, you probably typed in the equation wrong. So go back and, or maybe you put the wrong thing in the middle. You did your opposite of b over 2a wrong. So you need to catch your mistake and fix it when you don't see this symmetry in your table. Anyway, let's plot these points. So -1, 0 would be right there. 0, -3. And then let me keep the colors matched up. So 1, -4 would be right here. Alright, and then the symmetry takes over. And we've got 2, -3. Okay, you can see how those are mirror images of each other. And then 3, 0. Again, mirror images. Reflected over the axis of symmetry. Well, first let's go ahead and draw the parabola. I'm betting we can fit another point in here beyond the 5 from the table. Always fit another point when you can. You can get it right off the calculator, so why not? So the next point down is the point 4, 5. Let's graph that little puppy. Okay, so the point 4, 5 is like a bonus point. And the mirror image of it will also be there. So that just makes your graph more accurate. Okay, so why graph 5 when 6 will, when 7 points will fit? Let's go ahead and draw the parabola. Make sure you draw the parabola all the way to the edge of your graph. Don't let it stop at these, I've seen some kids do this. Some students, I shouldn't say kids. Some students do this. Okay? Don't draw your parabola. This is not connect the dots. Okay? These dots are guiding us to a curve. You need to make your curve go all the way to the edge of your graph, something more like that. Okay? Alright, so your parabola should look something like that. Now let's go ahead and graph that axis of symmetry. Always show your axis of symmetry as a dotted line right down the middle. So now we can go ahead and answer these questions. The vertex is what we started with, 1, -4. Is this vertex a maximum or a minimum? Well, the vertex is at the very bottom of the graph, so that makes it a minimum. This graph clearly opens up. We knew that right from the beginning, though, because the a value is positive. You know that the parabola will open up. The axis of symmetry, of course, is this vertical line at 1. So you must put x equals 1. Alright, it's always x equals. Don't leave off the x equals part. Don't just put 1. The zeros are the x-intercepts. We have x-intercepts here at -1 and 3. So let's say -1 comma 0 and 3 comma 0. The y-intercept is where the parabola crosses the y-axis, and that happens here at 0 comma -3. Alright, the y-intercept is always 0 comma something. The domain is the x values. So how far does the graph go to the left? How far to the right? Well, it goes left forever and right forever. So -infinity to +infinity. And finally, the range is the y values. So that means how far down does the graph go and how far up does the graph go. And it has to be in that order, least to greatest, bottom to top. So in this case, the lowest value is -4, and then it goes up forever. So the range will be -4 to infinity. Infinities always get round parentheses to show that you can't actually reach infinity, but -4 gets a square bracket to show that the parabola does reach -4. A value of -4 is included as part of this parabola. And in fact, you can see that -4 right there in the vertex, so it's definitely included. And that's it for realsies this time. Last time I thought it was it, and we really had the back still to do. But this time we did the back as well, so we really are done. I hope this video has been helpful, and I will see you on the next video.